In this video, I'm going to introduce you to functions. I'm going to talk about domains, ranges, function representations, and piecewise defined functions, and finally the vertical line test. All right. So what is a function? A function, think of it as a machine. Okay, first of all, it's a machine that eats numbers and spits out the same or different numbers. Okay, so let's say that I had a +1 machine. If I was to drop a 3 into the machine, it would spit out a 4 because the machine always adds 1 to the number. Okay, if I was to drop a 10 into the machine, it would spit out an 11. All right, you get the point? You can also, there's no reason you couldn't drop a negative number and add 1 to a negative number. Okay, so you can have machines that add 1, cut the number in half, square it, take the square root. There's no limit to what machines like this can do. Okay, we don't actually, when we work with machines, imaginary machines that operate on numbers like this, we don't actually write pictures, draw pictures of machines like this. What we will do, for a little bit more convenient notation, is we'll pick a letter name for the function, like F for function, and we will represent what goes into the function by a variable. We all know what variables are. And so the output we represent as an expression in terms of that variable. Okay, so this is the way that I would represent that function I just worked with. Okay, and if I was to drop a 3 into the machine, I would represent that by putting a 3 in parentheses like this, and then that would spit out a 4. The 10 would spit out an 11. The -7 would spit out a -6. Okay, so you will sometimes, you should think about what functions are in your head. It might, that would be perfectly fine to think of them as machines like I wrote there on the left. When you write on exams and homeworks on paper and you communicate with other people, you probably want to use the notation I have there on the right. Okay, and another notation that you can communicate with other people is you can call it f of x. You also, there's no reason you couldn't have called it g of x or h of x or capital I. The letter, just like variable names, function names don't matter. Sometimes people just call it y. So y is equal to x plus 1. All right, where y just denotes the same thing as f of x. Okay. Let's go back to the machine picture for a moment. So some machines you can only drop certain numbers into them. Just like a soda machine, you can give it American money, but you can't put foreign, like Canadian money. You can't put paper clips, rocks, and expect that it's going to give you a soda. Okay, likewise, you can't drop money into it and expect that you're going to get out a pair of socks or a new garden hose. All right, the soda machine will never give that to you if you give it money. So what am I saying? There's limitations to what it will accept, and there's limitations to what it will give. Okay, so these mathematical machines that I'm talking about some of them have those same limitations. All right, now mathematicians, when they talk about the input limitations, they call that the domain. Okay, the set of allowed input values. And then when they talk about the output, that's the range. That's the set of allowed, the set of possible output values. And an example is probably instructive here. So let me show you a new function definition. I'll do it in red in the bottom left. So let's say I had h of x is equal to the square root of x. All right, so is there any reason that any number, I can't take the square root of any number? And there is. You can't take the square root of a negative number unless you allow complex numbers, but let's assume that we have to stick with the reals. In that case, the domain is everything 0 and above, everything non-negative. All right, now if you think about it for a minute, you'll also notice that the range the square root. You'll never have the square root of no real number is a negative number. Okay, so the range is actually the same as the domain in this case, and often the range is expressed in terms of y. Y is a common, traditionally a variable that represents the output value. Okay, so let's do, that's an example where the domain and the range are limited. Some other things, some other common ways that the domain or the range could be limited. Let's say I had j of x was equal to 1 divided by x. Okay, in that case, the domain, you can do 1 divided by any number except 0. So the domain does not allow 0. And then it turns out for this example, the range is the same. Now, for every function, the domain and range are not always going to be equal. Okay, in fact, let me give you an example where they are not equal. So let's say that I had k of x is equal to 1 over 7 minus x. In that case, the domain is everything except 7. 7 is going to create problems because that's going to make the bottom be 0. The range, however, is everything except 0. See how they're different? All right. Now, you can define functions. I've given you expressions that define functions. You can have all kinds of different expressions that define functions. You can even make plots of functions, graphs of functions, and that's what I want to talk about now. So let's go back to f of x equals x plus 1. So you can make a table and you can plug in various values into that function and add 1 to various values, and you can make this table go as long as you want. Okay? Then you can plot those on an xy plane. And you can get the corresponding graph. In this case, the graph will be something like this. It'll have an intercept of 1 and y-intercept of 1 and an x-intercept of minus 1. Okay? Now, the reason that I'm mentioning all this is because you're going to have to get used to the fact that the same function, you can get information about a specific function lots of different ways. Okay, so the first way, the f of x is equal to x plus 1, that you might call that algebraic. I'm using variables, equal signs, all right, and that was certainly one way to give you information about a function. Now the middle way, where I had the columns there of numbers, you might call that a tabular, okay, because it has to do with a table of values. That's another way that somebody could communicate function information. And then on the right, that one would be graphical. All right. And so part of this class is going to get you comfortable thinking in all these different ways, and sometimes even in the same problem, being able to switch between these different ways of communicating information about functions. All right. And then another big way that I haven't mentioned yet is you might say verbal. Okay, that has to think word problems. Another thing you have to get good at is if somebody was to say, I have this problem in my roof, I don't know how tall it is, but I have this angle here and this length there, and you have to be able to translate a bunch of gobbledygook in English into either an algebraic definition of a function, get a tabular information, or make a graph of what's going on. All right. So this is the challenge. That's one of the challenges for this year, is going to be able to do word problems, solve real world problems, and then present your information or work with information in these different representations. Now let me say one more thing about graphs. So not every graph is the graph of a function. All right, not every function can have a certain type of graph. So imagine that I had a circle, okay? And I know that, is there a function that has that graph? Okay, well, I know that I could think of a function, I could make a table, and I could list here a couple of values, right? And I could find the y values. Here's the problem with a function having a graph that's a circle. All right, think about 2 points on the circle that are right on top of each other. All right, let's say that the x value for those is 2. All right, and let's say that the top is, 2 comma something, 2 comma 5. Okay, and the bottom, let's say, was 2 comma minus 5. All right, well, what is f of 2 for the function? Is it 5 or minus 5? Do you see the problem? So you can't have graphs for functions where you've got 2 points that are above, one of them is above or below another one, because otherwise for every x value you don't have a unique y value. Okay, so let me make that comment here. Graphs of functions must have unique must have one y value for all x values. All right, you can't have 2, all right, or more. That would be even worse. You have to have just 1. That's the point I'm trying to make. Now, if a graph can be the graph of a function, you're not going to be able to you're not going to see points on top of the other ones. All right, so for example, this curve could be a function. All right, likewise, a line like this could be a function. Okay, let's see what other kind of something. This would be fine, even if it had a little cusp like that. Okay, that could also be a function, because none of them can you make, are there points one on top of another one. Okay, now in fact, this idea of a point on top of another one, you can explain that to people. You can think about that as something called the vertical line test. Okay, if you want to know if a graph can correspond to a function, ask yourself, can I draw a vertical line anywhere on the graph that touches the function in 2 places, that touches the curve in 2 places? So that one's a function. I can't do that for any of these. If no matter what vertical line I draw, it'll only cut the function in one place. All right, let me give you some graphs that are, now you can see why the circle wouldn't work. Let me give you some examples of some graphs that don't pass the vertical line test at the bottom. I'll give you 2. All right, so how about something like a Z or a D? All right, so can you see that for those, I can, the Z, I can draw a vertical line, touches it in 3 points in some places. The D, I can touch it in 2 points. Okay, so those do not pass the vertical line test.